Experimental design is the blueprint for any scientific study. It outlines the methods and procedures that researchers will use to collect data and test hypotheses. A well-designed experiment ensures that results are reliable, valid, and replicable. Key elements of experimental design include defining the research question, selecting appropriate variables, determining the sample size, and establishing control measures. By carefully planning the experimental design, researchers can minimize bias, account for confounding factors, and draw accurate conclusions from their data. Ultimately, a robust experimental design is essential for producing credible and meaningful scientific results. Experimental design refers to the structure and layout of an experiment, and there are several types, each suited to different research goals and situations. Number 1. Pre-experimental design. This design involves a single group and lacks control or comparison groups. Examples include one-shot case study, one-group pretest post-test design, and static group comparison. Number 2. True experimental design. True experimental designs include randomization, control group, and manipulation of variables. Examples include randomized controlled trials, RCTs, and post-test-only control group design. Number 3. Quasi-experimental design. Quasi-experimental designs lack randomization or a control group. Examples include non-equivalent control group design and time series design. Number 4. Factorial design. This design involves manipulating two or more independent variables to study their effects on the dependent variable. Examples include 2 times 2 factorial design and factorial ANOVA. Number 5. Sequential design. Sequential designs allow researchers to make modifications to the study after data collection has begun, based on interim results. Experimental design is primarily used in quantitative research, where the researcher aims to establish cause and effect relationships between variables. It is commonly employed in fields such as psychology, biology, chemistry, physics, and medicine, among others. Experimental designs are particularly well suited for studies where the researcher wants to manipulate one or more independent variables to observe their effects on a dependent variable. Experimental designs are used in various types of research, including laboratory experiments, conducted in a controlled environment, such as a laboratory, where the researcher can manipulate variables and control for extraneous factors. Field experiments, conducted in real-world settings, allowing researchers to study phenomena in natural conditions while still maintaining some degree of control over variables. Randomized controlled trials, RCTs often used in medical and social sciences research. RCTs involve randomly assigning participants to experimental and control groups to test the efficacy of interventions or treatments. Quasi-experimental studies. Similar to true experiments but lacking randomization, quasi-experimental studies are used when random assignment is not feasible or ethical. Experimental design allows researchers to draw conclusions about cause and effect relationships between variables, making it a powerful tool for advancing scientific knowledge.